Yeah, well, it all started in the geology world. I worked at a university, and the core drills they had for 1-inch core samples were not very good. So I invented this one and got a patent and everything. And that was in about 1980. So I've been selling them ever since. I sell about 50 of them a year, so that's quite a few. Well, yeah, you know, this one sells to geologists who are doing paleomag work. Well, that's a pretty narrow market. So I wanted to appeal to a larger market. So construction industry is a much larger market, So I took the same motor and I designed a gearbox here that reduces the RPM, and it drives a 1.25-inch thread, which is standard in the large drill bits of all different sizes. So same motor, and these sell pretty good. Search and rescue teams, they like them because, you know, a rescue might happen because of a disaster, like an earthquake somewhere where they need to drill a hole through a concrete wall. And that's really great because it doesn't require electricity or anything else. You just plug it in, you got the portable water supply and extension hose that all snaps right on here, and you can drill holes up to 4 inches in diameter very fast. I mean, it'll go through a concrete slab like this old driveway, probably 4 inches thick, probably go through this slab in 3 or 4 minutes, and so it's very powerful. This was a chainsaw motor made by Still, and it's their 50cc model. Puts out about 2.5 horsepower or a little less, and turns out to be a pretty reliable motor. Sometimes they last. For the geology guys, you know, they'll get hundreds of 3 or 4 inch core samples with this motor. And this one here, you know, the geologists, they want a 1-inch diameter core sample for their lab equipment to fit in all their paleomag machinery or sensing equipment. And so this design is really cool because we use these bits that have a 1-inch inside diameter. And this goes together just by sliding this in and tightening it by hand. No tools are required, and it's a watertight seal in there. So again, you put your portable water supply on here, and you can drill 1-inch diameter core samples. And paleomag people, they need to know what angle they drilled at, and they need to know which way north is. So we make this device here. It takes a standard Brunton pocket transit, fits right in here, clamp it down, and then you can tell which way north is magnetically. And then you can also see what the plunge angle is with the protractor on the side. And then in case there's anomalies in the magnetic field, which happens in canyons, you can take this top plate completely off, which I'll just do it. And you can do sightings. If you know landmarks, you can turn your Brunton compass and do sightings and get your angle, get your location that way. Or if you leave this on here, you can take one of the shadow rods, take it out of the pocket in here, and put it in here, and you basically can get a sun angle shadow on this disc here, and that works great as long as the sun's out. So there's really 3 different ways to find where you are. So, and then once you find that information, you write it all down in your book. You number the core. You slide this device over the core. The brass rod slides in this slot, makes a mark on the core. That's the way it works. So I probably sell maybe 30 of these a year. So well, of course they're all made out of aluminum and stainless steel. So. Oh yeah, sure. Well, I mean, this is direct drive, which of course is, you know, two-stroke motor. They go 14,000 RPM. Well, of course you don't go that high when you're drilling. You're using up power. You might be down to 5,000 RPM. And if you were to go, say, 1,000 RPM, the thing would still drill pretty quick. This drill for construction or search and rescue is geared about something like 5 to 1. So the RPMs will be down in the 2,000 to 3,000 RPM range when you're drilling. Again, that's plenty for drilling holes up to about 4 inches, 100 millimeters outside diameter. It increases the torque by about 4 times, which you need for larger diameters. If you tried to drill a 2-inch hole with this direct drive, you'd be very hard pressed to do it because the RPM's too high. But so gearing this down works great. I have a customer that drills probably he's drilled a 5-inch diameter hole, which we manufacture all these aluminum pieces. They're all high tensile aluminum. This is high tensile stainless. The gears are heat treated. We cut the gears, and yeah, that's the way it works. Yeah, well, these, of course, geology samples, they only need about 4 inches, and or maybe 5. So this one here, you know, the standard bits, they're 14 inches long, and so you can drill all the way in easily, and you can break out the core. And then we have extensions you can put on, and you can drill. I have a customer that went 9 feet. He took out, you know, you have to use this series of tools that go in and break the core out of the ground, and then grab it and pull it out of the ground. And then you put on a longer bit, and you just keep increasing until you get down however far you need to go. I can't say I recommend anything more than about 10 feet, because all of a sudden the stack of cores and the stack of extensions gets kind of heavy, and so you'd probably need some help lifting it in and out of the hole. But it would do it. I mean, you can go 10 feet.